In this tutorial, we're going to look at conservation of momentum. Remember that by definition, in a closed, isolated system, such as a collision or an explosion, the momentum of the system is conserved. What that means is that the total momentum stays constant. So when you're given a situation, such as a collision or explosion, there's three basic steps that you're going to be following. First of all, draw a picture of what you have before and after the explosion or the collision. This will really help clarify what's going on and keep your variables straight. Label your velocity for each object before and your velocity for each object afterwards. Step 2, find the total momentum of the system. Either before or after, you'll have enough information to find the momentum of both objects. So find the momentum of both objects and add them together. Remember, if they're moving in opposite directions, one of them has to be negative. The third step that you're going to do is figure out your unknown by subtracting the total momentum, or the momentum that you do know, from the total. You'll always have enough information to figure out one of the unknowns using momentum, like mass times velocity. Use the total momentum to figure out the other unknown. So as an example, let's look at question number 3 in your assignment on conservation momentum and explosions. You're told that a group of pirates are firing a cannon during a naval battle. The cannon's mass is given and the cannonball's mass is given. You're told after the cannon is fired, it recoils with a velocity of 5.4 meters per second. So our first step is simply to draw a picture. There's our cannon. And there's our cannonball. Okay. Before the cannon is fired, both those things are going to be at rest. So the velocity of the ball is 0. The velocity of the cannon is 0. So because both objects have 0 velocity, that means both objects have 0 momentum. So I can say the momentum of the cannon is 0. I can say the momentum of the cannonball is 0 as well. So that tells me, since they both have 0 momentum, 0 plus 0 means that the total is 0 as well. Since momentum is conserved, that's the important quantity that remains constant. So that's our first step, is to figure out the before picture by drawing a picture and then calculating the momentum of each object and then adding them up. Here it's nice and easy. You're adding 0 plus 0, so your total momentum is going to be 0. After the cannon is fired, we're told that it rolls backwards at a velocity of 5.4 meters per second. So this is what our after picture might look like. Cannon's rolling backwards to the left, cannonball is moving forward to the right. The question is asking us to figure out the velocity of the cannonball. So since this is a closed, isolated system, that means the momentum is conserved. Back here we found the total momentum to be 0. That's what it means the momentum is conserved, is that the total momentum stays constant. So over here, I can go ahead and write down that the total momentum is still 0. We'll use the superscript prime like that to indicate after, so we don't get it confused with the before picture. So all I have to do to figure out the velocity of the cannonball is to figure out its momentum. To figure out the momentum of the cannonball, I'm first going to figure out the momentum of the cannon. So I'm going to say that the momentum of the cannon after the explosion is equal to the mass of the cannon. Don't really need the prime for a mass. Times the velocity of the cannon. Now make sure you use the velocity after it pushes the cannonball out. So that would be something like 360 kilograms times 5.4 meters per second. So when you do the arithmetic, you get something like 1,944 kilogram time meter per second. Once we have the momentum of the cannonball, now we can figure out the momentum of the cannon. Now we can figure out the momentum of the cannonball. I know that they have to add up to 0. So I'm simply going to say that 0 momentum is equal to 1,944 plus the momentum of the cannonball. So what number plus 1944 equals 0? Well, the answer would be negative 1944 kilogram meter per second. Now, it really doesn't matter to me which one you make positive or negative. Often the problem will say this has got a specific velocity of plus versus minus, but in this situation you're just told that it rolls backwards, one moves forward, so you can kind of define it either way you want to. What's important is we're all going to get the same final answer. Now that I've got the momentum of the cannonball figured out, it's real easy for me to figure out its velocity. Just take the momentum equation, solve it for v, and you would get momentum over mass equals velocity. So plug in your momentum that you just found, negative 1944, divide that by 12 kilograms. When you do that, you get something like negative 162 meters per second, and that's our final answer. Again, if yours is positive and mine is negative, it's no big deal, just so long as we get the same value. All the other problems on this assignment, you're going to work the same way. Start out by drawing a picture before and after. Find the total momentum of the system. Do that by figuring out the momentum of each individual part and adding them up. Remember, if two things are moving in opposite directions, they need to have opposite signs. One's positive, one's negative. And third, find the momentum of your unknown by subtracting the momentum of what you do know from the total. The total is what's going to stay the same. So remember, find that total first. That's the thing that stays constant.